Hi, Assalamualaikum and good day. I, Azwar, will presenting my final year project proposal. The title is Design of the Semi-Interface Motorcycle Simulator, SIMS, Windblast, Manifold, Mountings and Assemblies. As shown in the slide is my personal information. My full name is Ahmad Azwar bin Ariffin and my registered student ID is 2020840278. That is my personal email and personal phone number, and I'm under supervision of Dr. HELMI bin RASHID. There is 4 sections included in my presentation today. The first is project summary, and then background, methodology and expected result. For project summary, most of the motorcycle accidents are caused by human error, as Malaysian Institute of Road Safety Mirrors in 2015, they record that 80% of the motorcycle accident is caused by human error. However, there are several others causes that contribute to motorcycle accidents, such as speeding. Speeding reacts directly along with wind. The higher the speed, the higher the wind resistance to the body of the rider. There are no motorcycle simulation for research purpose has the features of Windblast system. Therefore, researchers from Motorcycle Engineering Technology Laboratory, Metal in UiTM Shah Alam, has consciousness on the importance of the environmental element to study on how the windblast could affect the handling and rider stiffness. The component included to create the windblast in this project is industrial blower and manifold to create a frontal wind to the rider and motorcycle simulator. Motorcycles are considered as a primary transport option due to their small and compact size, allowing them to pass through a narrow space between other vehicles and to use for the off-road rather than other type of vehicle. The two-wheel vehicle is invented as the most fuel efficient and easier to maneuver and used in most of the middle and low-income countries. Despite of its size, motorcycle contribute majority of the accident on the road around the world. Statistic in 2013, World Health Organization reported motorcycle fatalities is 23% in fatal road accident. And in 2015, Malaysia recorded 62% of the same category and road user, with increasing of 3% from 2013. This is proven that motorcycle is a popular mode of transportation in Malaysia and worldwide. There are actually several impacts that has been manipulated the handling of motorcycle, which can be the root cause of the motorcycle accident. One of it is windblast created due to the speeding and environmental element, which make a strong gust of wind as resistant to the body while controlling the motorcycle. The resistance created will uniformly affect the handling during cornering or even on the straight line, where more body force needed to control and maneuver the motorcycle. The windblast could also cause low visibility to the driver, as the wind could enter the allowance on the helmet, which will force our body to blink our eye. Moreover, without wearing helmet, the eye will be distracted by the dust, which resulting obstruction the view of the rider. The windblast system is invented to create a frontal wind which focus to the simulator and rider to obtain the experience of riding a real motorcycle. The industrial wind blower is improvised with additional of monitoring device to control the speed of the fan referring on the throttle and brake. It will be attached to a manifold to flow the wind, and the wind will be discharged from the nozzle targeting the simulator and the rider. Most of motorcycle simulation are built to do study on ergonomic of the motorcycle and rider human factor. As instance, the motorcycle sims, which is developed in University of Nottingham. The simulator is the first ever to has connected of STI sim drive which the software will present optical reaction to projector facing the simulator. Many of the motorcycle simulation did not have the Windblast system to be included as the factor of road accident amongst motorcyclists. The student has identified this problem as the Windblasts are considered a less important factor that contribute to road accident. There are two literature reviews that has been made for this project. First is Windblast impact on the motorcycle, and the second is air manifold mounting design. For Windblast impact on motorcycle, a person that handling motorcycle will encounter windblast as the vehicle moves. The windblast drag force to the body are dependent on the speed of the motorcycle travelling. The higher the speed of the motorcycle, the higher the drag force to the body created by the windblast. The windblast plays important part for the rider to control and maneuver the vehicle as more muscle involved in controlling the vehicle. More muscle will be activated for the human to uphold the posture of the riding motorcycle. This condition occurs because the thrusting force produced by the windblast will affect the riding posture as there are not many supports to hold the body to maintain a riding posture. Besides, comfortability is more or less important for the motorcycle rider. Another important element is the intervention of airflow created by the windblast. The airflow will affect the rider reactivity and stability while handling the vehicle. The second one is air manifold mounting design. Air manifold is a design which could flow a high pressure air to several outputs. The manifold design must have ability to flow the air in one direction and withstand a high pressure condition to discharge the air. However, the flow of air from industrial blower, which is not high, the area of size of circular and rectangular manifold is crucial to ensure that the air will flow without any delay or problem. The most important aspect needs to be considered is the mounting, as the mounting will hold the manifold fixed into its place. The purpose of manifold involved in this research is to ensure that the windblast created and functioning well. As for now, the industrial blower did not fulfill the requirement to create enough windblast effect. The design of the mounting must meet the requirement of a specific guidelines and criteria to ensure it is functional, cost-saving, and safe to use. Human consideration must be addressed in besides only technical and economic concern. It is necessary to acknowledge a proper design requirement during the planning and development process. Next is problem statement. There is no motorcycle simulator constructed has the windblast impact on it, and it is the main problem for this research. Design of manifold mounting for flowing air to create windblast need to be examined to ensure that the windblast system functioning fully to its purpose. As for now, the simulator using industrial blower to create windblast on the simulator. The system did not fulfill the requirement to create enough windblast effect as there is no manifold mounted specifically for the simulator. The objective of this research is first to analyze the design parameter of manifold mounting for windblast system. Second, to design the detailed manifold mounting specifically for semi-interface motorcycle simulator. And lastly is to validate the detailed design of mounting using CAD software for semi-interface motorcycle simulator. Scope of limitation for this project, I am focusing to achieve the following objective. So the research done for this project have some scope of area to be covered. Firstly, the design of the mountings are referring to the size of the confined space ventilation fan. I'm allocated that this scope is limited to a person that use motorcycle for their daily transportation. The range of age are between 16 to 25 years old to help for data collection. Male gender is chosen for data collection as it is easier and proper to use rather than female because the shirt will be taken off during the data collection. There's reason why I choose this range of age and gender because statistics show that this age and range and this age range and the gender are the highest contributor to the motorcycle accident. For methodology, there is 4 phases. The first phase is initial study, where information is gathered and product design specification is done. In phase 2, concept generation, I use morphological chart and path chart to get my concept design. And the third phase is design of the manifold mounting. I use CATIA to design my mounting. And lastly is the fourth phase. Computational fluid dynamic CFD will be analyzed using the ANSYS. For information gathering, I use 3 methods, which is questionnaire, literature review, and observation. For questionnaire, I distribute a survey question to the user to understand what are the wants, needs, and knowledge. The survey asks about the general information and demographic data of the respondent. The survey is about the respondent's experience using motorcycle, and lastly, Windblast and Manifold mounting are also included in the survey. The second one is literature review. I choose literature review are the main source of data that the student can obtain. Article, journals, and books are reliable source with proof of study, which can help student to gain the information and decide which design is suitable for this project. And lastly is observation. Observation is another method of gaining information and idea for the design. Through observation, the idea of the design are imaginable, as almost exact design can be obtained from the object surrounding. There are several factors that I choose for my product design specification. The first is physical detail. The material used to create the manifold mounting must have ability to flow the wind and withstand a specific pressure, so that the manifold did not detach from the simulator and industrial blower. The mounting also need to be focused on, because it is need to be easy to assemble and disassemble. The purpose of this need to be focused is for easier setup and maintenance, or replace when the manifold is no longer can be used. The second one is functionality. The mounting must withstand pressure and not moving when wind hit at some point. The airflow inside of the manifold can flow through easily without any obstruction that cause the airflow to be interrupted. And lastly is the manufacturing. The expected manufacturing process involved for producing my design is, first is cutting and grinding. Next, for the joining process will be welding, bolt and nut. So here is my morphological chart. From this chart, I get 3 concept design. And this is my path chart. From this path chart, concept 1 score the highest net score. So I choose the concept 1 to do for my preliminary design. For expected result, first is result from questionnaire. I has distributed a survey of questionnaire as I present before. The expected respondent for the survey is 40 respondent, and I managed to get 43 response. So this is my preliminary design. The conceptual design are based on the morphological chart, and the criteria to have the best and functional design are using path chart. Then CAD software used to design the selected conceptual mounting design is CATIA. The dimension of the mounting are based on the dimension of the confined space ventilation duct. The design have 2 main parts, which is the upper part and the lower part. So the upper part is the curved steel, and the lower part it will have a stand. The stand will be mounted to the simulator, and the upper and lower will be attached using a bolt and nut. And this is the Gantt chart that has been made for my FYP1.